Hello, my name is Mark Walker. I'm from 3SL. I'm here to talk a little bit about our requirements management and system engineering tool Cradle as a prelude to a more detailed training session that's going to be happening in the near future. The purpose for the conversation today is really just to set the scene a little bit, to give an idea as to what Cradle is really all about, and to give a bit of context for the training session that will be happening shortly. So what I'd like to begin by doing is to just talk a little about the sorts of problems that Cradle is seeking to solve, to describe what Cradle is in simple terms and give an idea of its benefits and some of its example applications and usage, and the extent of a program or project's lifecycle that Cradle can potentially cover. And to begin that then, the problem that Cradle is fundamentally trying to solve is a problem which is very common in a whole range of projects of various industries, various sizes, various scopes. A problem that fundamentally is that a lot of projects' documentation, a lot of the project's information is held in linear documents. Now, documents in that sense, we're suggesting, are quite a major problem. They're fundamentally linear. They have a first page and a second page and a third page and a fourth page, and you typically start reading on the first page and you make your way to the second and to the third and to the fourth. The problem with that is that the information inside those documents isn't linear. Typically, the information is hierarchical. Typically, the information is in the form of a graph where a piece of information links to many other pieces of information, and each of those other pieces of information in turn links back to many others and forward to still more. So the information that's being conveyed in a document isn't a simple sequence of linear facts or statements, this and then this and then this and then this, but rather that information is very complex and interlinked, and a document is simply one possible linear slice through it. In that sense, then, when we look at a document, that is simply one way of collating a collection of underlying information. A document is simply one way of assembling some of that information, assembling it together in a particular order and presenting it to you. It would be equally possible for other documents to be created from that same information, each of those other documents collating perhaps slightly different collections of those underlying facts, collating those perhaps slightly different collections in slightly different orders, presenting those slightly different orders to you. In that way, many documents could potentially be produced for the same collection of facts, or based on or derived from the same collection of facts. So, the first problem with documents is that they're linear. The second is that searching in them is difficult. If we want to find all instances of a particular piece of information, we have to search each document, search the next document, search the next document, search the next document, search the next document. And that searching process is very slow and inefficient. Even if we try to do it in parallel, which, given the tools available to most of us, we can't. Being simplistic about it, one could open a first Word or PDF file and search for the text of interest, Fred, and then go to the next PDF file or Word file and open it and search for Fred, and so on and so on. And if one has 1,000 documents, then, worst case, one has to open 1,000 documents and individually search for Fred, and then try in some way to present all those references to or usages of Fred at the same time on the screen. Now, of course, 1,000 is an exaggeration, but it's an exaggeration to achieve a point. In practice, there probably wouldn't be 1,000 documents. There probably wouldn't be 1,000 instances of a particular search term. But even if there are 10 or 20 or only 30 such documents or instances, even that is a significant manual effort. It's difficult to link between documents. That's to say, if in a document I'm referring to a piece of information which is defined in a part of a separate document, then that link is difficult. Typically, that link is a textual, see page such and such, section such and such in this other document, reference or file such and such. It's very rare for those links to be navigable. Now, of course, that's a lot easier if that information is presented in some kind of hypertext-based solution, typically something like a wiki. That's a lot more straightforward. It's possible to make those direct links, but 99% of the information that we work with is not presented as a collection of hyperlinked web pages, certainly not as a wiki. It's typically as Word documents and PDF files, and the links between those documents, those separate Word and PDF files, are difficult to create and virtually impossible to maintain. If you have 100 documents or 1,000 documents and you have 100 inter-document links or 1,000 document links, I think it's a pretty safe assumption that the majority of those inter-document links will become invalid after those documents have been revised once or twice. If those multiple documents contain duplicated information, then any changes to any of those pieces of information must be made in exactly the same way in all of the places where it's duplicated. And that, of course, is an inherently very time-consuming, very laborious, and perhaps more importantly, very error-prone activity. Because we have these documents and their content will change, and we produce new versions, new releases, new issues of those documents, it's important to us to understand who has received each of our documents, and so who needs to be told that each of those documents have been updated when they are updated, so as to ensure that each of the document's recipients does indeed have the latest issues of all of the documents that are relevant to them. Now, that in itself is a time-consuming activity and one which is inherently difficult to achieve with any degree of certainty. And then finally, of course, documents are fundamentally uncontrolled. It's easier to copy Word documents or PDF files and send them to people who perhaps shouldn't have access to them. It's easy to print those documents and to change the printed copies and pretend that the documents say something which it doesn't actually say. It's also possible to change the contents of those documents, notwithstanding any claimed encryption or password protection that the documents themselves may have. There are claims of applying passwords to Word documents. There are claims of applying passwords to PDF documents. And equally, there are claims of hacks, of ways of circumventing all of those password protection mechanisms. So there's fundamentally an issue of the control of those issued documents, whether as paper copies or as soft copies, and there are issues with the content and validity and integrity of those printed or soft copies. So, in summary, all projects use documents, but documents are a problem. So what isn't the solution then would be a system to manage documents, because all that is doing is automating some of the peripheral, well, perhaps that's slightly unfair, but let's continue with it, the peripheral activities related to documents. That is to say, their life cycle, the process by which a document goes from being something that is inherently draft and is being actively worked upon by one or more authors into a finished article. Documents provide a controlled review and issue of documents. They manage documents as indivisible entities. But as we've already said, the document contains a whole collection of information presented, unfortunately, in a simple linear sequence. And it's those individual pieces of information that are perhaps more worthy of careful control than the arbitrary collection of them embodied in a particular document. Now, perhaps if each document's contents were disjoint from the contents of all others, then this approach may work of managing documents as individual entities. But since the content of the documents in a project are inevitably highly interrelated, this indivisibility, this disjointness of documents' contents never occurs in practice, which further undermines the use of document management systems as a way to coordinate and review and control the review and issuing of that information embodied in these artificial document constraints. So a collaboration tool that allows information to be entered and interrelated is perhaps a useful interim step. It is perhaps a useful improvement over a simple document management system, but unfortunately those collaboration tools lack the rigor and structure to enforce user access rights and roles correctly, to add characterizations of the data, and are fundamentally limited in the way in which they allow information to be queried and searched based on its relationship to other information. So, if a document management system or simple collaboration tools aren't the solution, then what is? Well, we, of course, with a fair degree of bias, it has to be said, we believe that the solution is a system that manages the piece of information found inside the documents and interrelates those pieces of information to those that depend upon it and those that it is dependent upon, allow new information to be related to the data that's already present, and allow that data to be published in an arbitrary collection of documents, each of which is structured in whatever way happens to be most appropriate, while still providing full traceability of all of the changes that are made to those underlying pieces of information, and allowing full configuration control over each of those pieces of information that are assembled into the documents. And that, or these, are the role of requirements management and systems engineering tools. And as the developer and vendor of such a tool, 3SL is of course completely biased in believing that requirements management and systems engineering tools such as our Cradle product are the solution to the problems of managing information through the vehicle of linear documents. And on this slide then we have some definitions over what requirements management as a tool, as a term means, what systems engineering as a term means. The definitions there are collections of words. They're not really important, although unfortunately they are often the subject of intense debate, perhaps somewhat pointless inside the professional engineering communities. Fundamentally, what we're suggesting here is that our Cradle product, being of course completely biased as a tool vendor, our requirements management and systems engineering tool Cradle contains a whole range of capabilities that we believe make it far better suited to managing collections of information. These kinds of approaches are becoming increasingly widely adopted across a whole range of industry sectors, including the ones listed at the bottom of the slide. So, fundamentally then, what is Cradle? Well, fundamentally, it's a database. It's a database into which you can load any amount of any type of information, be that by pulling individual pieces of information, sentences, words, paragraphs, tables, and so on, from documents, or pulling data from other tools, or just by manually entering it into the tool. So Cradle is a database into which you can load any amount of any type of information. And then you can define relationships between these pieces of information. And it's the ability to define how pieces of information relate to each other that separate Cradle and other tools such as Cradle from just being the same as a flat, simple MySQL, Access, SQL Server, or Oracle database. So Cradle is a tool, a database into which you can load any type of information and then relate those pieces of information to each other. And having done that, you can then query that data. Find me all the information that meet these pieces meet these criteria, or find all of the information that is linked to this piece of information, or find all the pieces of information to which this piece of information is linked. When we're querying, then we're querying not only based on the contents of these pieces of information, but on how they are interrelated to others. And terms such as coverage, compliance, and traceability become an important part of the way in which we think about our information and the way in which we search it and the way in which we develop it. Cradle then is a database into which you can load any type of information, define relationships between them, query that information, and then track and control the evolution of that information. So Cradle will automatically track every change that everybody makes to every piece of data in the database. At least it will if that's what you want it to do. Cradle is also a tool that can generate metrics of that data, KPIs, and have dashboards of those key performance indicators. So how complete is our set of requirements? How many of our requirements have been allocated into a system breakdown structure? For what proportion of our requirements do we have test cases or acceptance criteria developed? Or perhaps even a little further, what proportion of our requirements are indirectly linked to test cases that succeed? And then finally, Cradle's a tool from which we can, yes, generate documents, because notwithstanding everything that I've said so far about documents, they are and will continue to be an integral part of the business of conducting projects. That fundamentally, projects will still produce documents. Documents are a useful embodiment of the project achieving particularly key events in its life cycle, of it completing specific milestones. And here I think about things like URDs, the SRD, the SDS, the SSDS, RTMs, PVMs, and all of the other plethora of standard documents that have entered our lexicon that are inherent in the management of projects defined by, for example, the PMBOK. So as a picture then, Cradle, think of Cradle, if you would please, as a big database. The nice thing about it is that database has a structure that you decide. You decide what types of information are going to be held inside this database. You decide what attributes each of those pieces of information will have. You decide how they're interlinked, how they're going to be related to each other, what types of relationships will exist, and what types of information can be linked to what other types of information. And then you decide the life cycle of each of these pieces of information. You decide how, for example, user requirements will evolve over time. You decide how governance statements will evolve over time. You decide the life cycle of issues and defects. You decide the life cycle of test cases and test results, if you want those types of information to exist in the database. So the Cradle database, as drawn here, is a big empty space that you fill with the types of information that you want, with each of those types of information having the component attributes that you want, that are interlinked in a way that you want, and that have life histories, life cycles that you want. So that database is then filled with documents that we can load from external sources, and Cradle provides tools to help with that. We can load data, upper right corner of the slide, with data from external tools, be those document processing tools, Microsoft Office, LibreOffice, those kinds of things, be they raw data files, be they pieces of data from other requirements management or system engineering tools that other organizations may use, as well as directly entering the information by hand. And then bottom left corner of the slide, we apply a process, a set of requirements management and system engineering tasks to that data. So Cradle is a database with a content and structure that you define. We bring data into that database from external documents, external tools, and manually entering it. We apply a process to that collection of information. We do that to derive new information from that which already exists. So we create system requirements from user requirements. We assign system requirements to a system breakdown structure that we've devised. We apply a design process to parts of that system breakdown structure. We conduct validation and verification activities. And ultimately, perhaps within the tool, we assign acceptance criteria and monitor our progress against those acceptance criteria. Whatever our process is, it will be for you to decide what your process is or which parts of your process you want to insert into the Cradle database. It will be for you to decide which parts of your process are to be represented within Cradle. And having done that, then the red arrows on this picture start to apply. We can then get information out of the database. We can get, at around 5 o'clock or so, graphical views of how information interrelates. They look a bit like organization charts. We call them hierarchy diagrams. At around 3 o'clock on the diagram, we can get compliancy and coverage views, which are, from Cradle's point of view, trivially easy to produce, but from your point of view, I hope you will come to think massively useful. It shows how every piece of information is linked to every other piece of information. It would show you which system requirements have been allocated to each part of our system breakdown structure. It would show how each customer need has been represented as user requirements. It will show how each acceptance criteria indirectly satisfies each customer need. It would show how different parts of an organization breakdown structure have been allocated to the different organizations involved in a series of service deliveries. All of these interrelationships can be shown not only as these graphical views, but also as these, we call them nested table views of coverage and compliance and traceability. And then, shown at 3 o'clock in the diagram, you can produce documents from the tool. So we're still living in that real world, that document-centric real world, but now documents are, inverted commas, simply one way of looking at our database. They're, inverted commas, simply one way of slicing, taking different slices through our database and producing as Word PDF files particular subsets of that database, with all the benefits that we'll get from those documents being produced from that single source. Benefits that we'll come on to talk about shortly. When we're capturing documents into Cradle, we call them source documents. On the left-hand side of this picture, we have 2 example source documents. And here we're trying to show that each of those source documents can exist in multiple versions, multiple issues or releases. We start with the source document, and we have tools within Cradle that will automatically split that document into a hierarchy of sections and subsections. And each of those individual sections and subsections, sentences, table rows, table cells, and so forth, are automatically assembled into a hierarchy. That hierarchy reflects the hierarchical structure of the document. Each of the, as Cradle calls them, items in that hierarchy will have many attributes. I'm showing them here as test, acceptance, origin, reference, test method, and status, but the set of attributes is chosen by you. It's not mandated in any way by Cradle. All that we're saying is that we take our source document, we automatically parse it into a hierarchical structure of items, each item having many attributes inside it. And each of the items in that hierarchy is linked back to its origin in the source document. It's linked back to the table row or the table cell or the paragraph that it came from in that document, so that from a Cradle perspective, it's always possible to navigate back to the original source document and see these pieces of information in context. And then we can do this, as you can see, for several source documents, each of which becomes its own hierarchy in the database. And then on the right-hand side of the slide, we can take these multiple source documents, bring them each into their own hierarchy of needs or user requirements, and then potentially merge them into a single set of information that become the basis for the later stages in our project lifecycle. So multiple source documents are each brought into multiple needs or user requirement hierarchies that in turn are satisfied with a single set of system requirements that in turn get mapped into the service delivery architecture or the system breakdown structure, or if it's a product, a product architecture. And then back to the left-hand side of the slide, as the source document changes, as its author, your customer, issues a new version of that source document, then Cradle will automatically find the differences between the old and new versions of the document and show you which of the requirements that you've captured may need to change to reflect that new document version. And you can then decide if you want to accept these changes into the database or not. And if you do, then that will update some of the needs or user requirements that you've captured previously. And the fact that those items have been updated will then, in Cradle, automatically mark everything downstream as potentially requiring change. So we bring in a new version of a source document that updates information in the database and marks everything downstream as being, in Cradle jargon, suspect as potentially requiring change, which then prompts you to act upon those source document differences and reflect them in the rest of the information in the database, or indeed, of course, having taken stock as to the scope of those downstream effects, to potentially reject that new version of the document and go back to its author to renegotiate. Now, I mentioned that the Cradle database is an empty shell that you fill with information that is appropriate to your process, to your circumstance, to your project. What we have here is a simple box and line diagram that shows how Cradle could be applied to managing bids, where we have information that comes from the customer in the upper left, and perhaps from external regulators whose standards and codes and regulations have a bearing upon the project that we would be undertaking. And then from these customer RFPs, we might produce consolidated requirements. If we're involved in subcontractors, we might partition those requirements into sets of partitioned requirements. We might have candidate solutions which evolve into a preferred solution through a set of justifications. We may have measures of performance that characterize those partitioned requirements and are used to judge the efficacy of a preferred solution, and so on. This is a box and line diagram that suggests nothing more, that suggests types of information that might exist in a Cradle database that's being used to respond to a customer RFP, ITT, ITN, whatever the circumstances are. Excuse me, I need a drink. Particularly in the context where we have prime and subcontractor, this is not how Cradle works. This is simply how Cradle could be configured. If you think this is reasonable, good. If you think it's inappropriate or overly complex, that's fine. The structure of a Cradle database is entirely within your control. And here is an example of the use of Cradle as a means to explore traceability, and particularly using a property that's unique to Cradle of so-called indirect or transitive relationships. In this example, we have 9 sets of information represented by 9 boxes. each set of information has been directly linked to its adjacent set of information with cross-references. So we've created user requirements, upper left corner, we've created some use cases, and we have linked those together with relationships in Cradle. And then we have linked the use cases directly to the system requirements that we've created in Cradle, and so on, so on. Having done all of that, then the user requirements, upper left corner, are of course indirectly linked to the acceptance criteria, upper right corner. We have not created links between user requirements and acceptance criteria in this example, but those sets of information are obviously indirectly linked to each other by virtue of the chains of, in this case, 8 links, 8 green arrows. The cross-reference is represented by those 8 green arrows. There are some indirect relationships between the user requirements and the acceptance criteria. Cradle is uniquely able to show you those, or let me say that differently, only Cradle can follow those chains of multiple links to reveal those indirect relationships to you. The end result of which is simply that Cradle can give you traceability from anywhere to anywhere across lifecycle, which is, of course, extraordinarily helpful, powerful, beneficial, and all those other good words. Cradle is not an out-and-out project management tool. Now, what I mean by that is Cradle does not have the functionality to process programs, PERT charts, Gantt, arrow precedence networks, calculating start-finish times, resource usage, doing time and resource analysis. Cradle doesn't do that. Cradle does support a work breakdown structure if you wish to use it. Cradle can exchange information directly with MS Project. Cradle can manage task lists. Cradle can allow you to allocate users to tasks and then present users with a tailored task list of the things that they need to do. In fact, Cradle can do everything in the PMBOK except for anything related to the stuff at the top of this slide, the start-finish times and resource usage for a PERTing Gantt analysis tool. So Cradle can embody the PMBOK if you want it to, but Cradle is not a substitute for those time and resource analysis tools that I'm sure you use already. So what are the benefits of Cradle? Why are we suggesting that it's a good thing for you to spend your time looking at? Well, fundamentally, it's a single point of truth. All of the information exists once only in one place. Therefore, you only need to make changes to it once. You don't have to make changes to a piece of information wherever it appears. So it's a single point of truth. It gives you knowable relationships. You know where every piece of information is used. You know what every piece of information depends on for certain, without any ambiguity. You know the impact of any and every change that you make. If you change a piece of information, you know with absolute certainty what the effects will be of that change. If you simply look at a statement, a sentence in a document and say, I'm going to change 25 to 30, whatever it may be, degrees Celsius, millisecond delay in this sentence, you don't know what effect that change will have on the 20, 50, 100 other documents that embody the rest of your process. With your project's description. You don't know what the effect of that change is, but with the information held inside a database all linked together, you do know. This means that you get, number 3, guarantee consistency and accuracy in all outputs. Each piece of information exists once, which guarantees the accuracy and consistency of all outputs in all project deliverables. And that's a big thing. I'm sure we've all been part of projects where in the old days we would print many boxfuls of information which might be put into the back of a transit van and delivered to the customer. I've certainly been in projects that have done that sort of thing. And when we did it, we had no real guarantee of the complete consistency of every page in every one of those thousands of documents. Well, when all that information comes from a single point of truth database, you do have that guarantee. Number 4, access controls. If you need to restrict access to data, you can. If you need to partition access, you can. If you need to partition data between subcontractors, you can. Automatic change traceability. You've got a complete record of all changes. You know when every change was made, who made it, what they did, and why they did it. You know that. You know that you can reverse it should you need to. You know what the impact of every change is going to be before you make it. You know what other bits of information may be impacted by your change. And if you then make changes to those impacted pieces of information, you know what other further pieces of information would be impacted, the second order effects, or the third order effects, or the fourth order effects. The total scope of any change is knowable before you make it, which gives you an automated development history. You've got a complete record of the bid response and all rebids. You have a complete record of the as designed and as built systems. You have full justification for all differences. So if your design, be it a product design or a service design, evolves over time, as inevitably it will, then you have the means in Cradle, if you wish, to record those intermediate stages of that evolving service or product design history, as designed, as built, as commissioned, as operated, and so on. Some example applications. Cradle's quite big in the space industry, with a standard tool in NASA for all manned spaceflight, aviation, bottom right, things that fly around and sometimes go bang, automotive upper left, bits that exist inside cars, engine management systems, vehicle stability systems, and so on. Naval, we're quite big in naval, particularly nuclear, with a standard tool for requirements management and system engineering in the entire US nuclear aircraft carrier program. Bottom left, communications, that's G345 cellular networks and more traditional networks, and construction at the bottom, be that more traditional construction projects or specifically nuclear, where the standard tool across a whole range of new nuclear build projects in the UK, in France, in Finland, in China, and other such places. So example uses of Cradle: for tenders, contractual statements of work, load the customer contracts into Cradle, split into component parts, create verifications for each, produce bid documentation with compliance statements. If you believe that some degree of automation, some degree of additional control over your bid response process would be helpful, if you believe that it would be helpful to have a more data-focused rather than document-focused process, then Cradle is certainly a candidate tool for you to implement those revised bid response processes. For tender or contractual statement of work assessment, again, you can define the same kind of idea. You can define the contractual statements, generate tender documents from Cradle, receive bid responses and load into Cradle, link each set of responses to the tender statements and analyze those responses. So in that sense, the third, fourth, and fifth point of item number 2 are a corollary to the points for item number 1. For contract fulfillment, we can use the same kind of approach, now not for bidding for the work, but for managing the work as we conduct it for our customer and as our subcontractors conduct it for us. And in that sense, Cradle can sit as an intermediate repository of information between sets of incoming documents on the one hand, documents that come in to us, and sets of documents that we produce on the other hand out to our partners and suppliers. So on the left hand side of this picture, Cradle is sat there receiving documents from the customer and generating documents to the customer. Of course, it would be ideal if the customer had Cradle themselves. And on the right hand side, where we are supplying to our customer and we have people who supply to us, again, Cradle can be receiving documents that come into us from our customer and producing documents to our customer and to our suppliers. And of course, from 3SL's perspective, it would be ideal if all parties were using Cradle. So Cradle is capable, if we wish it to, of supporting quite a wide range of our life cycle, of our project life cycle, managing needs, goals, objectives, codes, regulations, standards, requirements at all levels. It's capable of supporting us with logical analysis models. It's capable of supporting us with be that service or product architecture and design models, and it's capable of supporting us all the way through the V&V activities, the verification and validation, everything from low-level verification through integration test to validation up to acceptance, and capable of supporting all those activities that occur throughout the life cycle, shown in blue across the top of this picture. This does not mean that Cradle must be used for all these things, however. It doesn't mean that you can only use Cradle if you use Cradle for every part of your process. The starting point is always you decide which part or parts of your process you would like to put into Cradle, and then you configure that Cradle database to support those parts of your process. And it's that database configuration that is going to be the starting point for the detailed Cradle training that we've been talking about. So the scope of Cradle can be anything that you would like it to be. And here we have some examples of the types of activity that Cradle can be used to, Cradle can be applied to in a whole range of different contexts, whether that is simply applied at multiple levels, or whether it's applied in more of a phased or agile process where we're still applying the same V cycle, but we're doing so iteratively. Excuse me. Another slurp of tea. So in summary, requirements management and system engineering tools are uniquely, we contend, able to manage project information. We believe that such tools eliminate the weaknesses and inefficiencies of a traditional document-centric, document-based approach. To do the work in the requirements management or system engineering tool, we believe is the way to go. Don't do the work inside documents, do the work in the tool, manage the contractual relationships in the tool, and potentially do both. Cradle from 3SL is an example of such a tool with a full lifecycle coverage. It's been proven in a whole range of industries over many, many years. It's got the power and scalability that we believe your projects will require. It can support any process, including agile and phase-based activities. It's got an open and flexible architecture to bring information in from a variety of sources and to push information out to a variety of sources, be that external tools, or just simple external data sources. And it can be the center of a project tool chain or just part of an existing framework of tools that you may already be using, and Cradle can perhaps fill a little gap that might otherwise exist as you hopefully make that transition from a document-centric view of managing and creating your information to a data-centric view of managing and creating your information. Now, I hope that this has been useful. I hope that this has been helpful, and I hope that this will provide some context for the more detailed Cradle training that will follow. That training will probably start with a look at how to define a Cradle schema when you have decided that Cradle is an approach that you want to take, and you have decided, or as you're deciding which parts of your process you would like to put into the tool. The next step is then to configure that Cradle database, to define, to create what we call the schema, and the training will start, I'm sure, by taking you through those activities to define the schema, to configure Cradle so it will work in the way that you want it to work, as a prelude to then managing the contractual information, managing the requirement, generating the documents, and delivering benefit. I'd like to thank you for your time. I hope this has been helpful and informative. Once again, my name is Mark Walker from 3SL. My email address is generally quite widely available, but it's mark.walker@3sl.com. That's THRESL.com. S for sugar, L for Lima.com, and I'd be delighted if you wish to email me to hear from you. Thank you very much, and goodbye.